Welcome to this explainer. Today we're literally shattering the classic tropical dinosaur stereotype by digging into some truly shocking fossil evidence from the extreme ends of the Earth. I am super excited to share this with you today because it totally flips the script on everything we thought we knew about the Mesozoic era. Let's leave those swampy jungles behind, shall we? So we all grew up picturing dinosaurs living exclusively in these sweltering, humid jungles, right? The classic pop culture image is always this massive reptile basking in endless sunshine, totally dependent on tropical heat to keep its cold-blooded engine running. But what if I told you they actually thrived in places that got freezing winter snow? Yeah, it's time to ditch that tropical myth of the endless summer. Instead, consider the polar reality. We're talking brutal conditions here, mean annual air temperatures hovering right around freezing, and ecosystems plunged into total pitch-black darkness for months on end. It's a completely different world from what we're used to imagining.
Which brings us to Section 1, Alaska's Extreme Dinosaur Nursery.
Let's kick off our investigation at the top of the world. Now, to really grasp how extreme this Alaskan environment was, we gotta look at its paleolatitude, which is basically just where a landmass was positioned in the geological past. Millions of years ago, tectonic plates were shifted, and the Prince Creek Formation wasn't just far north. Its paleolatitude placed it at 80 to 85 degrees north. That is deep inside the ancient Arctic Circle. And what's absolutely fascinating here is the sheer diversity of the fossils we're finding. We've got theropods like the tyrannosaurid Nanosaurus hanging out alongside dromaeosaurs like Troodon. We see ceratopsians like Pachyrhinosaurus paratorum and massive hadrosaurs like Edmontosaurus. So this wasn't just a couple of lost wandering species. This was an entire thriving ecosystem of giants living right at the top of the world. Okay, here is the massive bombshell of this explainer. Are you ready? A staggering 70% of known dinosaur families in this formation are represented by perinatal or baby fossils. We are talking about microscopic teeth and incredibly fragile unformed bones from little guys that had either just hatched or were actually still inside the egg. Now you might be asking, why are baby dinosaurs such a big deal? Well, because they prove these animals weren't just summer tourists. You see, these dinosaurs had prolonged incubation periods, sometimes taking several months. So by the time these tiny neonate babies hatched, that short Arctic summer was already ending. With their tiny sizes and winter rapidly closing in, there is just no way these babies could migrate thousands of miles south, which means these dinosaurs were permanent year-round Arctic residents. Moving on to Section 2, 120 Days of Darkness. Since they couldn't migrate away from the poles, they had to face a pretty harsh reality. The sun simply didn't rise for 4 months. They had to survive 120 straight days of total, unrelenting winter darkness every single year. Just imagine trying to forage for enough food to fuel a multi-ton body in the pitch black. Wild, right? But it is important to note that their home wasn't just some barren, sterile sheet of ice like Antarctica is today. Actually, scratch that. It wasn't a sheet of ice at all. It was a dense, boreal-like conifer forest, packed with ferns and flowering plants. The mean annual temperature was warmer than it is up there today, sitting around 6 degrees Celsius. But make no mistake, it was still cold enough to get sub-freezing temps and heavy snows during those dark months. It was a rugged, demanding environment, and they shared it with other tough survivors, like Kulasuchus, a giant labyrinthodont amphibian. Next up, Section 3, Australia's winter foragers. Let's flip over to the exact opposite end of the Cretaceous world to look at Australia's Victoria. Back then, it was actually attached to Antarctica, sitting at a paleolatitude of 75 to 80 degrees south. Down here at the bottom of the world, we find a really cool cast of characters, like apex predators such as Cryolophosaurus, and smaller theropods like Timonius. They lived in mean annual temperatures swinging anywhere from -6 to +10 degrees Celsius. And anatomical studies show us something incredible. Small ornithopods and theropods down here actually had enhanced night vision, letting them actively forage straight through those freezing winter nights. So you're probably wondering, if they're trapped in sub-zero temperatures for months on end in total darkness, did these polar dinosaurs just sleep it off? Like, did they just shut down and hibernate the way modern reptiles or some mammals do today? To figure that out, paleontologists rely on bone histology. It's basically reading microscopic slices of fossilized bone exactly like you'd read the rings of a tree. They're looking for a specific pattern. First, woven fibered tissue, which means rapid, chaotic bone growth when the animal is young. Second, parallel fiber tissue, showing slower, mature growth. And third, LAGs, or lines of arrested growth. These mark cyclical pauses in bone building. It's kind of like hitting pause on construction for the winter. Well, when researchers took the bones of these high-latitude polar dinosaurs and compared them directly to their cousins living in warm, equatorial environments, the microscopic forensics were absolutely shocking. Polar dinosaurs had the exact same growth trajectories and bone microstructure patterns as their relatives living in the heat. Identical. The big takeaway here? There is absolutely zero osteohistologic evidence to suggest these polar dinosaurs were hibernating. Sure, they paused their growth briefly during tough times, just like their tropical cousins did, but they did not go into a deep, prolonged hibernation. Nope, they were awake, they were active, and they were fighting to survive in the snow and the dark. Which brings us to Section 4, the warm-blooded smoking gun. When we tie all this evidence from northern Alaska and southern Australia together, it leads to one undeniable, paradigm-shifting revelation: endothermy. If you're not familiar, endothermy is the physiological capability to internally generate and maintain your own body heat. In plain English, it means being warm-blooded. It's a biological engine we usually associate with modern mammals and birds, definitely not with giant ancient reptiles. But when you compile all of the source material, the picture is just crystal clear. We've got continuous, rapid early bone growth. We've got active winter foraging with enhanced night vision. We have dinosaurs nesting and raising incredibly vulnerable babies in freezing, 4-month-long darkness. A cold-blooded reptile relying on the sun for warmth simply cannot pull that off. To survive this, insulation became absolutely critical. And this is the evolutionary pressure that likely drove feather development in theropods in these polar settings, far beyond just simple display. They needed those feathers to survive the cold. As our analysis reveals, these incredible survivors of the polar extremes aren't just some weird anomaly. They are literally the strongest argument we have in all of paleontology that dinosaurs were warm-blooded powerhouses. They were generating their own internal heat to combat the ice. Think dinosaurs needed tropical heat? No way. Alaska and Antarctica had entire thriving ecosystems of dinosaurs living through months of total darkness and winter snow. They nested there. They raised their young there. They didn't leave. The polar dinosaurs are the strongest argument we have that dinosaurs were warm-blooded. And honestly, if these ultimate rulers of the freezing dark were warm-blooded, active animals, what other ancient pop culture myths are just waiting to be shattered? Thanks so much for joining me for this explainer, and remember to keep questioning what you think you know.